Hello everyone, welcome to CIPMAT. Today we are going to start our new series called Concept Booster series, and today is the session 1 for Concept Booster series, and the topic that we are going to cover in today's class is a very beautiful topic. It's known as the Cevas Theorem. The Cevas Theorem is basically a concept related to geometry. By geometry, I mean Euclidean geometry and not coordinate geometry. It's a very beautiful topic related to triangles. Okay, this particular theorem is going to be really helpful in further understanding and solving questions related to various things where it involves three lines which intersect each other. So, for example, you must have heard of the centroid. You must have heard about the orthocenter, about the circumcenter, about the incenter. So this Cevas theorem will be really helpful and it will be applicable in all those kind of diagrams which involve those centers or centroid. Okay, so let's get started with today's session. First of all, let me introduce myself. I am currently a IPM fifth year student at IIM Indore, and I have done my foreign exchange at EM Lyon in France with specialization in finance. And I have been the coordinator of mathematics and statistics special interest group at IIM. Along with that, I also conducted a lot of tutorial sessions in the classrooms of IIM Indore for my junior batches in multiple topics related to quantitative ability, like statistics and mathematics. And also, I'm an international certified teacher of QMath, along with the experience of teaching Canadian and US students. So apart from that, I am also a student. I'll keep learning from each and every one of you. Now, I welcome every one of you, every IPM aspirant to CIPMAT. And these are the courses. These are some of the beautifully crafted courses by IIM Indore alumni, okay, which CIPMAT is offering to you. Okay, the most, the course that will be starting within a day or two is this particular course, that is the live crash course, which will be mainly focused towards IPMAT 2021. For IPMAT 2022 and 23, we have the 1 year online course and 2 year online course for class 11th and class 12th respectively. Okay, so for class 12 and 11th respectively, and these courses are going to start from the month of August. And apart from that, we also provide you with test series and personal interview preparation. Please visit our website and check out these courses. So these are basically the links that you can find out, and of course you can contact us in these phone numbers. Okay, our team members are going to be in touch with you once you contact them and you get to subscribe for our courses. And these are some of the very important links that you have regarding our website and the various social media channels. Do check them out. And now let me talk about some tips and tricks related to IPMAT. So remember, guys, IPMAT is a test which tests your ability on a relative basis. That means it is a test which is going to test of your intelligence, but not only your intelligence, but intelligence per unit time. Your speed matters. That means all kind of short tricks are very much necessary for you to learn. All right. So we'll look at point number 3. Conceptual clarity on topics to be tested will be making it very much easier for you during the examination. So hence this series we have, that is the Concept Booster series. Of course, we are going to practice a lot of questions and we will be covering these concepts in detail in our live courses. Okay, but here to give you a brief idea about the main concepts, we have started this series called Concept Booster series. Of course, if you like the video, please give a like and subscribe to our channel. And so without wasting any more time, let's get started with today's class. So we are going to learn about the Cevas theorem in today's class. So what is the Cevas theorem? बहुत अच्छे से और बहुत ही धीरे धीरे हम लोग को इसको समझेंगे, ठीक है, अच्छे से समझना. So just consider any triangle. Okay, let me draw a triangle. So suppose you have any triangle like this, And okay, that's a beautiful triangle that I have drawn over here. Okay, and of course, let me name them. Okay, जैसे कि सब लोग नाम देते हैं A, B और C. ठीक है? Now consider any three coincident, any three lines, okay, which are intersecting at a particular point, such that these lines are passing through the vertices of the triangle. What do I mean? देखो ध्यान से. See, from A, I am drawing a line. Okay, I am not telling, just remember, I'm not telling that this is a median, this is an altitude or anything. I'm just a random line, okay? Just a random line. Let me draw another random line like this from B. Okay, I have drawn another random line from B. Okay, similarly, I will draw another line from C such that it passes through the point of intersection of the previous two lines that I have drawn. Okay, and let me name these points. Let's say this is D, let's say this is F, and let's say this is F. Now, according to Cevas theorem, according to Cevas theorem, what we have is, we have this particular thing that is AF upon FB multiplied by BD upon DC multiplied by CE upon EA, which will be equal to 1. Now, this is a very cool theorem. Okay. How do you remember this? Why is it a cool theorem, by the way? It's a cool theorem because this applies to any kind of triangle. This applies to any kind of triangle such that three lines are intersecting at one point, passing through the vertex. This is going to hold. Okay, this is going to hold for the diagrams that you draw for centroid, that is the point of intersection of the medians. Okay, this is going to be holding for orthocenter, which is the point of intersection of the altitudes. Similarly for circumcenter as well, which is the point of intersection of the perpendicular bisectors. Do think about it, whether it's going to be applied for here or not. Okay, but for altitudes and centroid, of course, it is going to be for centroids and orthocenter, of course, you can apply this theorem. Okay, but abhi ke liye jitna samajhna hai, utna samjho. That is, I have just three lines from A, B, and C intersecting at one point, and I say that AF upon FB multiplied by BD upon DC multiplied by CE upon EA is equals to 1. Okay, so this is your Cevas theorem. Do remember this particular thing. Okay, now how do you remember this? इसको याद रखना कोई बड़ी बात है ही नहीं. तो AF upon FB क्या है? ये तुम्हारा AF हो गया, ये होगा तुम्हारा FB, है ना? ये BD हो गया, ये DC हो गया. सबको लाइन से लिख दो, लाइन से लिख दो, ठीक है? CE upon EA लाइन से लिख दो, एक के ऊपर एक लिख दो, हो गया खत्म. AF upon FB, ठीक है? BD upon DC, मैं कलर करते जा रहा हूं, देखो. AF upon FB, BD upon DC, CE upon AE, ठीक है? याद रखना कोई बड़ी बात है ही नहीं, बहुत आसानी से याद रख सकते हैं इस चीज को, है ना? चलो, अब हम लोग आते हैं इसका मेन पार्ट पे, जिसको बोलते हैं प्रूफ. इसका प्रूफ देखते हैं, ठीक है? अभी यू विल बी आस्किंग दैट वेदर द प्रूफ इज रिक्वायर्ड फॉर IPMAT or not. Of course not. The proof is not, nobody will ask you in the exam that इसका proof निकालो, इसका proof बताओ कि ये ऐसा होता है. You just need to know the result. तो फिर तुम लोग पूछोगे कि तुम लोग IPMAT के लिए पढ़ा रहे हो, तो प्रूफ क्यों दिखा रहे हो? देखो, proof is important because it will show you how to approach a problem. Okay, the way I am proving this, that will show you how to approach this kind of a problem. And if you can learn that how to approach this kind of problems, okay, it will be really helpful for you to approach other problems related to geometry, which are given in your examinations. Okay, so let's get started with the proof of this particular thing. So before I go into the proof, I would like to tell you something. That is, let's say that you have a triangle like this. Let's say you have a triangle like this. And let me name this triangle, of course. Let's say this time it's P, Q, and R. Okay, this is the triangle that I have. And let me just draw a simple line like this. And let's name this point M. Now, can you tell me what is the ratio? What is the ratio of the areas of triangle PQM divided by the area of triangle PMR? This is going to be simply QM upon MR. I hope this everybody knows. Why is this true? इसका proof कोई comment box में लिख देना, ठीक है? चलो, इसके बाद हम लोग इसका आगे बढ़ते हैं and let's see the proof of this particular theorem. So let's see. Can you tell me what is AF upon FB? Or let's just go with BD upon DC. BD upon DC. Can I say that BD upon DC is the area of triangle ABD upon the area of triangle ADC? Can I say that? Yes, of course I can say that. Okay, now again look into this figure properly and let's say that this particular point is L. Okay, let's say that this point of intersection of these three lines is L. Then can I say that BD upon DC is equals to area of triangle BLD divided by area of triangle CLD? Can I say that? Of course, I can say that. From these two things, can I write that BD upon DC is equals to area of triangle ABD minus area of triangle BLD divided by area of triangle ADC minus area of triangle CLD? Can I do that? How can I do that? This is by the rule of ratio and proportion. If you remember the theory of ratio and proportion, there was a rule called addendo. Okay, that is x upon y is equals to, let's say, m upon n is equals to, let's say, a upon b. According to addendo, this will be equal to x plus m plus a divided by y plus n plus b. Now, instead of plus, I can replace them with the negatives or as well. Okay, hence this particular rule. Okay, by using this particular rule, which is addendo for ratio and proportion, I can write this particular line. Now, if you look into the figure, then you will be able to realize that now I can write from here that BD upon DC is equals to triangle ABD minus triangle BLD. What is that? Triangle ABD minus triangle BLD. Look into the figure and see what is it. It is equal to what? It is equal to triangle, the area of triangle ALB. Did everyone notice that? I hope everybody has noticed this one. Okay, triangle ABD minus triangle BLD is equals to the area of triangle ALB. Similarly, if you look into the denominator says that what is the area of triangle ADC minus area of triangle CLD. If you look into the figure carefully, you will see that it's area of triangle CLA. Isn't it? Yes, of course. Let me name this as equation 1. तो यहाँ पे ध्यान से अगर तुम लोग देखोगे, then in this particular thing, in this particular figure, okay, you will see that you will see over here that BD upon DC is this triangle is to this triangle, isn't it? This triangle is to this triangle. Now, similarly, can I say that similarly AF upon FB by the same logic, just like equation number 1, by using the same logic, can I say that AF upon FB is equals to area of triangle ALC divided by area of triangle CLB? Yes, of course, I can write that. Okay, similarly, another thing that I can write is AE upon, not AE, let's say CE upon EA. What is this? This can be written as CE upon EA can be written as area of triangle BLC divided by area of triangle ALB. Isn't it? Yes, of course, this is correct. Okay. Now let me name these things like this. Let me name that this is 2 and this is 3. Now let's further take up this particular concept in the next slide. Okay, for that, I will copy this part to the next slide and okay, just a second. As you can see, I have taken up the part from the previous slide. Okay, now you can clearly notice from here, that I have equation number 1, I have equation number 2, I have equation number 3. इसके बाद मैं क्या करूंगा, ध्यान से देखना. Okay, I will multiply equation 1 multiplied by equation 2 multiplied by equation by 3. I will multiply these three things. If I multiply these three things, what will I get? See, BD upon DC multiplied by AF upon FB multiplied by CE upon EA. Okay, this is what I'm going to get. And this will be equals to, you see, area of triangle ALB divided by area of triangle CLA. This is from equation number 1. Then from equation number 2, I'm going to get area of triangle ALC divided by area of triangle CLB. This is from equation number 2. From equation number 3, I'm going to get area of triangle BLC divided by area of triangle ALB. Now look into this equation very carefully and tell me this one. You see over here, ALB and ALB, these two things get cancelled with each other. ALB and ALB gets cancelled with each other. Similarly, you see CLA, which is same as area of triangle ALC. This is the same as this one. So this can cancel with this. And of course, this will cancel with this. So I will be left with what? I will be left with a 1. And what have I proved? If you look into this thing that I have just proved over here, it's nothing but AF upon FB is AF upon FB multiplied by BD upon DC multiplied by CE upon EA. This is equals to 1. And if you notice this carefully, is this what I was trying to prove? Yes, of course. If you look into this, okay, this is your Cevas theorem. Hence, I have proved the Cevas theorem. But यहाँ पे I have done this lamba chaura proof over here. But why is the proof necessary again? This is to tell you about the various concepts that I have used. Okay, यहाँ से अगर तुम proof देख लिए तो यहाँ पे तुम लोगों को सिर्फ एक concept Cevas theorem नहीं पता चला. इससे तुम्हें और भी concepts पता चला. जैसे कि, for example, you have learned about addendo in this particular video. You have also learned about this concept in this particular video, and you can see that how you can exploit these two concepts to approach a geometrical problem. So these are the things, these are the learnings that you should take away from this particular video. If you have any doubts or any particular question related to this video, please post in the comment box. And also please like and subscribe this video, subscribe the channel, and do share this with your friends, the people who are giving IPMAT, and do subscribe for our courses. Thank you very much. And all the best for your, all the best for your IPMAT examination. Bye-bye.